All right, let's look at question 19 from CAT 21 slot 1. A, V, M can complete a work alone in 15, 12 and 20 days respectively. V works every day. A works alternate days starting the first day. M works alternate days starting from the second day. Number of days needed to complete the work is how many? Options are there. Now, standard work cycles question from the time and work chapter. We have a standard approach to do this. The only other advice outside of the standard concept is to maybe not take 1 as the total work, take some other value, ideally LCM of these numbers given to us. That will make the subsequent calculations easier. So question 19, I would say let the work be 60 units. 60 is a common multiple of 15, 12 and 10, in which case A can do 60 units in 15 days, which is 4 units per day. V and M can do 5 and 3 per day. These are their daily outputs. Now, what do we have? We have particular cycles given to us, which is V works every day, 5, 5, 5, 5 and so on. A works alternate days starting the first day, so that's a 4 on the first day and the third day, but not on the second or fourth. Then you have Manu works on alternate days from the second day, so that's a 3 on the second day and the fourth day, but not the first day or the third day. Now this will repeat. This is a 2-day cycle and your output is 17 units in 2 days. Once you find 17 units in 2 days, you can say that in the next 2 days you will do another 17. Any 2 consecutive days you will do a total of 17 units. So that's the standard approach to this, which is find out the number of units done in a complete cycle and then extrapolate over complete cycles until you can't do any more complete cycles. How do you find that? You had a total of 60 units to do and 17 units per cycle, which gives you 3 and something. That's 3 complete cycles plus an incomplete cycle. In this 3 complete cycles, we have done 3 into 17, 51 units. Notice 17, 17, 17 is 51. Cumulative is 51. 17, 34, 51. After which what happens? After which on the 7th day, this is 6 days. 2 plus 2 plus 2, 6 days. The 7th day you do another 4, 5. We start over and restart the cycle. Another 4, 5. That's another 9. Notice that the cumulative at this point is 60 units, which means that the work is complete. How many days has it taken? Notice that it was 7 days, which is the answer. So we have a standard approach, which is find out the recurring pattern in how the work is done, which is this pattern right here. How much work was done? 17 units. How many days did it take? 2 days. Now 17 units will continue to be done in every set of 2 days. The speed that we found here, 17 units for 2 days, can be extrapolated over complete cycles, but it cannot be extrapolated over incomplete cycle. Notice that this averages to 8.5 per day, but this is actually 9 units per day. So yeah, what do you find for a complete cycle? Extrapolate over however many complete cycles will fit into this 60, which can be found by doing 60 by 17 and taking the integer part. Whatever is left is done in the last incomplete cycle, which you'll have to analyze on a day by day or hour by hour basis, depending on how the question is given to you, and then use that to find the total number of days, which in this case is 7 days. So that's the standard approach. The only suggestion, if you're not already doing it, is to similar with the case with most other question types in time and work, start taking work as LCM of the given times, leading to easier calculations. So that's question 19. Let's look at question 20. 20 says how many 3-digit numbers are greater than 100 and increase by 198 when the 3 digits are arranged in the reverse order. Two concepts are coming in: digit reversal from number systems, and then a very trivial instance of FTC, fundamental theorem of counting, from combinatorics. Now, any expert solver who will solve this very fast would already know that if you take a 3-digit number and then reverse the digits to create another 3-digit number, and then you subtract them, let's look at the values. If the digits are ABC, the value is 100A plus 10B plus C, and CBA was the reverse. It's 100C plus 10B plus A, and if you subtract these, you are going to end up with 100A minus A, 99A. 10B minus 10B just cancels out, and then C minus 100C is going to give you minus 99C. It's basically 99 times A minus C. The difference between a 3-digit number and the 3-digit number formed by reversing the digits is 99 times the difference between the extreme digits, and the middle digit really doesn't turn up in this difference at all. The difference is independent of the middle digit. This is what you would know if you have practiced this chapter and application questions already. You would know this. And they specifically say increase by 198. So that means, I'll give you a numerical example. So something like 153. When you reverse it, it'll become 351. It's a bigger number. That's a plus 198. I skipped a step in between. What is 198? 198 is 2 times 99. 2 times this 99, which means the extreme digits differ by 2. A and C differ by 2. But more than that, they're saying increase by 198, so you have to start with the lower number and end with the bigger number, which means you should have a smaller digit on the left end and a higher digit on the right end. Middle digit can be anything. So the extreme digits differ by 2. Hundreds place digit is smaller and the units place digit is larger. They differ by 2. Middle digit can be anything. Now this is true even if I change the middle digit, let's say 173, 371, they also differ by 198, and 173 will increase by 198 when you reverse it, plus 198. This is not true for 351. If you start with 351, you'll have to reduce by 198 to get to 153. So this does not work. This works. This works. And instead of 1 and 3, I can say 4 and 6. 476 increases by 198 to give you 674. So you should already know that the difference between the 3-digit number and its reverse is 99 times the difference between the extreme digits, and it is independent of the middle digit. Because they say 198, you should know that the left digit is smaller and the right digit is 2 bigger. 2 because 198 is 2 times of 99, and the middle digit can be anything. This is what we are dealing with in question 20. Now A has to be at least 1. Otherwise it will not be a 3-digit number. They've explicitly said that this number has to be greater than 100. So A has to be at least 1. But you also know that A plus 2 has to be at most 9. Which means that A should lie between 1 and 7. B can be anything between 0 and 9. It doesn't matter. And at this stage we can invoke fundamental theorem of counting and say the left dash can be filled in 7 ways. The middle dash can be filled in 10 ways independent of what's happening in the left dash, and the rightmost dash will fill in a very specific way depending on each value in the leftmost dash. So this is not really adding anything, adding any more cases. So 7 into 10 into 1, 70 different ways of filling these 3 dashes in accordance to these constraints. And so you'll have 70 different 3-digit numbers that satisfy this condition. So yeah, a digit reversal we have a standard approach to doing that. Place value expansion, flip it and do place value expansion again, and when you take the difference, see what happens. Ideally, if you know this result already, you would save a lot of time. And the other concept in this question is the very basics of combinatorics, fundamental theorem of counting. Let's move on to the next question. Question 21. A very standard trains crossing question. There's not much there. Two trains cross each other in 14 seconds when running in opposite directions along parallel tracks. The faster train is 160 meters long and crosses a lamppost in 12 seconds. If the speed of the other train is 6 km per hour less than the faster one, its length in meters is how much? Four options are given. Question 21. Now there is one standard formula for the time taken by objects to cross other objects, either or both of them may be moving. Objects with lengths crossing other objects with lengths when they are moving, and that formula is T is equal to L1 plus L2 divided by S1 plus or minus S2. If it is same direction, you use a minus in the denominator. If it is opposite direction, you use a plus. So in this case it is opposite, so I'm going to use a plus. That's the formula. Now every other scenario, so this is two trains crossing each other, they both have lengths, they are both moving. Every other scenario, like a train crossing a railway station, a train overtaking a bike, a train crossing a lamppost, they're all reductions of this general formula. So here both objects have a length and both have speed. What happens when a train crosses a lamppost? The lamppost doesn't have a length in the horizontal direction, which is the one that matters here. Ignore its height. So L2 is going to be 0 and it's stationary, it's not moving, so S2 is also going to be 0. So in the case of the train crossing the lamppost, the faster train crossing the lamppost, this same formula reduces to T is equal to L1 by S1. Nothing much in this question, just direct application of very standard formulae. What are the values given to us? We have the two trains cross each other in 14 seconds. This T right here is 14. You know what? I'm just going to put the number there. Forget the circle. That's 14. Opposite direction, so we have a plus already. That's sorted. The faster train is 160 meters long and crosses a lamppost in 12 seconds. When you solve for this equation, you will see that S1 is 40 by 3. This is in meter per second. Now, the difference between the two speeds is given as 6 km per hour. So minor optimizations which are not necessary, you can still get the answer without using these optimizations. People might have a temptation or a tendency to convert this to kilometer per hour and then subtract 6. But you will notice that then you will get S2 in kilometer per hour and you will have to convert it back to meter per second. So let's not do that. Let's keep S1 as 40 by 3. Do not even convert it to 13.33. Not yet. Hold off on intermediate calculations. See whether you need to do them or not, and do them only if you need. So that's S1 is equal to 40 by 3. What is S2? S2, L1 is also 160, right? S2 is 6 kilometers per hour less. What do we know? We know that 5 meter per second is equal to 18 kilometer per hour. That's the conversion, right? So 6 kilometer per hour, that's the delta, should be 5 by 3 meter per second, which means S2 is 5 by 3 less than 40 by 3, which is 35 by 3. Again, not an integer. You don't need to convert this to 11.67 meter per second, because when you add these two things up, you get 75 by 3. 75 by 3 is 25. Notice how fine-tuned the numbers are. This is the greatest takeaway for acing quants in competitive exams. They build the question data around easy calculations, leading to nice round numbers. So anyway, we have S1 plus S2 is 25. We have T is 14. which means when you solve, when you make this the subject, L1 plus L2 the subject, uh, that is going to be equal to 25 times 14, which is 350. 25 times 14 is 350. 160 plus what number gives 350? That should be 190. So the answer is 190 meters. There we go. Standard formula. I don't think there's anything to say there except, minor optimization in terms of how do you go about with the unit conversions. Other than that, everybody who solves this would pretty much solve this the same way. Let's look at question 22. Last question in the slot. I don't think there's a very particularly smart way to solve this. Again, just like last question, everybody who gets this would solve this the same way. 22, it's tagged a recursive function. As an additional hint, I've mentioned it's periodic. This is a spoiler. I should not have looked at this yet. Let's look at the question. It is given that x0 is 1, x1 is 2, and there's a recursive definition. Xn plus 2 is, I should put this somewhere else. Xn plus 2 is 1 plus xn plus 1 divided by xn. So this is kind of like the Fibonacci series. Fibonacci series also has a formula where an output depends on the previous output and the output before that. And so to be able to use that formula, you should initialize the first two outputs, which is the same thing that's happening here. First output x0 is 1, x1 is 2. So now we have two values, and every subsequent value is a function of the previous two values. And so this is going to be a function of this and this, and this is going to be a function of this and this, and so on. And so based on this formula, before that, so we have a recursive formula, hence the concept tag. Recursive function. Oh my god, where do we go? Oh my god, 21. Question, yeah, recursive function. So let's see what happens. Now, before you do that, this is a purposefully ridiculously large number, which should basically tell you one or two things. Either there is a periodic nature of the outputs, it's repetitive and you can find the period and use that, or there might be a non-recursive explicit definition. Now, an explicit definition would not depend on the previous outputs. You can just use the current input and find the output. Either of these two things should happen, otherwise this is not solvable, right? So it doesn't matter how big this number is. The bigger it is, the more confident that I am that there is a very neat trick that will help me solve this, right? So you have x0, x1, and you find x2. You see if you can find the pattern. Again, the other comment I've given here is pattern recognition. X2, what do we have? X2 is 1 plus previous value divided by the one before that. So that's going to give you 3. X3 is 1 plus previous value divided by the one before that. 3 by 2 is 2. X4 is 1 plus previous value divided by the one before that, and you will get 1. What happens after this? You take x5, it is 1 plus previous divided by the one before that. 1 plus 1 by 2 is equal to 1. What is x6? 1 plus this by this. 1 plus 1 by 1 is 2. x7 is 1 plus this divided by this. 2 by 1 is 3. x8 is 1 plus 3 by 2 is equal to 4 by 2 is 2. x9 is 1 plus 2 divided by 3 is equal to 1. This is actually enough. You can see the pattern 1 2 3 2 1 1 2 3 2 1. It should continue like this. So we have a recursive function which gives outputs corresponding to an integer subscript, where the periodicity is 5. The sequence is 1 2 3 2 1, and then it continues with another 1 2 3 2 1, and we know it will continue with another 1 2 3 2 1. So now you take the subscript 2021, just mod it by 5 because 5 is the period. Periodicity is 5, so mod this by 5. 2021 modulus 5 is 1. So the output should be this 2. Answer is 2.